Today we're looking at maximum and minimum, as well as a little bit more on transformation. So let's start off with this function right here. We're going to start off with something we already know, which is finding the intervals when the function is increasing and decreasing. So increasing, let's start at the left side of our function. From here all the way until this point, our function is increasing, because from left to right it's going up. And so it starts, this arrow means it keeps on going from negative infinity all the way until our x value, which is -2. And then it's also increasing from here on to the end. So this is a x value of 3. Arrow means it keeps on going, so again, infinity. Alright, so increasing are those two sections. Decreasing now is when it's going down, so the section in between. Again, always use your x values. So this is starting at -2. And ending at 3. So be careful. The most common mistake I see here is people are using their y values instead of their x values. So knowing this, now we can give some definitions to maximum and minimum. So a maximum occurs when f changes from increasing to decreasing. So if the function was increasing, so if it's going up and then suddenly it starts going down, that is when a maximum occurs, which makes sense because it's essentially like at the top of a hill. So if we look at this problem right here, we can find a maximum. So this is when it's increasing, 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 and then it starts decreasing right at this point. So this is our maximum right here. Now our maximum, of course, has two values associated with it, an x and a y. So our max is at -2, 4. That's my x and my y value. There's two different things I can ask for here. So when you are asked where f has a max, f has a maximum at x equals -2. So this is your x value. Whenever you're asked where it is located, so where the max occurs, this maximum occurs at x equals -2. That's when you're asking for your x value. Whereas if they're asking you what it is, the maximum is 4, which is your y value. So two different things you could ask for, either your x or your y. So in this case, f has a max at x equals 2, that's your x value. The max is 4, that's your y value. Now let's look at our minimum. So our minimum is when f changes from decreasing to increasing. So it's just the opposite. So if it was going down and suddenly it starts going up, that's the point where your minimum is going to occur, just like at the bottom of the valley. So let's look up here and find our minimum. So it is decreasing, decreasing, and then it changes to increasing right here. So this is our minimum, and our x value is 3, our y value is 0. So our minimum is happening right here, 3, 0. So again, f has a minimum at, if they're asking you where it's located at x equals 3. That's your x value. What the minimum actually is, the minimum is the y value, which is 0. Okay, so let's take a look at another problem. The graph below shows, here, the figure below shows the graph of f of x. At what value, if any, does f have a maximum? So if it's asking you at what value, so where it is, this is asking you for your x value of your maximum. And there could be more than one. So remember, our maximum is it's increasing and then it changes to decreasing. So increasing changes to decreasing. This is the maximum right here. Decreasing, decreasing, increasing, increasing. And from here, again, increasing changes to decreasing. Here's another maximum. So we actually have two maximums. And they're asking us for our x values of our maximums. So our x values are, this one has an x value of -7. This one has an x value of +7. So we have two x values for our maximum. Part B is asking us what are the maximums. So if you're asking us what, this is now looking for the y value. So the y value of our 2 maximum, it's actually the same y value here. It's a y value of 3. That is what the maximum is. So let's justify our answer. Why are these maximum? These are maxima because f changes from increasing to decreasing at x is equal to -7 and 7. Right, so that's our justification right there. A maximum, the definition is it changes from increasing to decreasing. So if that's what's happening, then those two must be maximum. Okay, let's look at part D now. At what value, if any, does f have a minimum? Again, at what value is asking you where is looking for the x value. So if we look at our minimum, minimum is when it goes from decreasing to increasing. We only have one. It's right here. So our x value here is just 0. X is equal to 0. What is the minimum? Now we're looking for our y value. Our y value of minimum is -4. Okay, now let's really quickly go through domain. So domain, this is going off the graph, so let's just imagine there's arrow signs. So left to right, the domain here is -infinity to infinity. Is f even, odd, or neither? So remember, even is y-axis symmetry, odd is origin symmetry. So let's see if this has either one of them. So is this symmetric across the y-axis? In this case it actually is, so this is an even function. Now let's do range. So range starts at the bottom, goes up to the top. The arrow means it keeps on going, so it starts at -infinity and it stops at the topmost point is a 3. Because there's no hole there, it's included, it's going to be a bracket. Okay, finally, we're going to end off with some more transformations. So these are transformations, but this time instead of transforming a whole graph, we're just going to transform one point. So we're going to start off with the point 5, -1. And we're going to transform this one point using these 3 different transformations. So let's start off with A. So in this case, 3 times f of x. 3 is on the outside, so this is affecting our y. So we know we're going to be multiplying our y by 3. So if our point is 5, -1, when we multiply the y by 3, this turns into 5, -3, and that's my new point. That's all this one is. For B now, this +4 is inside the parentheses, so this is going to be affecting our x. Because it's affecting our x, we know it's the inverse operation, so we're actually going to be subtracting 4. So now if we're subtracting 4 from this 5, it gives us 1, and our y stays the same, so it's still -1. That's our new point. Last problem here, C. We have 3 minus f of 2x. So this one looks a little bit different. So let's actually first rearrange it. So I'm going to put the negative f of 2x first, and this is going to be a +3. Once we rearrange it, this should look a little bit more familiar. Okay, so this negative is outside of the f, which means it's going to be affecting our y value. The 2x is inside, so it's affecting our x. But remember with x's, it's the inverse operation, so this is going to be x divided by 2. +3 is on the outside, so again, it's affecting our y, -y +3. So, if our point is 5, -1, this is our x, this is our y, we're going to do 5 divided by 2, which gives us 2.5. And then in this case, for our y, -1, we're going to change the sign, so it turns into a +1, +3 will give us 4. And this is our new point right there.